Okay, so this video today is us going over pretty much all things right triangle trigonometry. You've done a little bit of this in Algebra 2. We did a lot of it back in geometry. So for the last 2 years, you have seen right triangle trig. And today we're kind of going to smash all of that in to one little lesson for the most part. So starting here, if you have a right triangle and you know two sides of the right triangle, it is imperative that we know how to find the third side. To do that, we use the Pythagorean Theorem. This is a middle school math topic, but in a right triangle, the hypotenuse squared is equal to the two legs squared added together. So 15 squared plus x squared is equal to 20 squared. 15 squared is 225 plus x squared is equal to 400. When we subtract 225, we get that x squared is equal to 175. And then x would just be the square root of 175. For today, we don't need to worry about simplifying this. To simplify this, it would be 5 times the square root of 7 if you want to get a estimation in your calculator. You just type in square root of 175, and then you can press Control, Enter, get the squiggly, we get 13.23. For this certain problem, we don't need to worry about the plus or minus out in front because we're talking about the length of a side. Another topic to review is we don't like having square roots in the denominator of fractions. So what we need to do is we need to what's called rationalize the denominator. So if you have 5 divided by the square root of 2, you can multiply top and bottom by that square root. And what that does is on top you multiply straight across, you get 5 times the square root of 2. And on bottom, you get the square root of 2 times the square root of 2, which is the square root of 4, which is just 2. So that's us rationalizing the denominator. Okay, so this page is your big page for right triangle trigonometry. So everything we're doing on this page is in regards to a certain angle. We'll call it theta. This is a Greek letter. From theta, this is one of the non-90 degree angles in a right triangle. The hypotenuse stays the hypotenuse. The adjacent side is the side touching the angle that's not the hypotenuse. And the opposite side is the side that's directly across from the angle in question, in this case, theta. So to recap our 3 main trigonometric ratios, the sine ratio is the opposite side over the hypotenuse. Cosine is the adjacent side over the hypotenuse. Tangent is the opposite over the adjacent side. So opposite and adjacent. So the vertical change, horizontal change. We also have the reciprocal functions, which you learned in Algebra 2, but not in geometry. Cosecant is just sine, but flipped, so hypotenuse over opposite. Secant is the reciprocal of cosine, so hypotenuse over the adjacent side. And then cotangent, which is the adjacent side over the opposite side. Where these 6 ratios come from, we're not going to dive too deep in this video. Just know that for all triangles, regardless of size with a certain angle, the ratio of the sides has to remain the same. So it doesn't matter what size or what lengths the triangles are, it's just these ratios are always the same. Remember, we can remember our main 3 trig ratios using the little mnemonic device SOHCAHTOA. Sometimes we say it like this: sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. For your reciprocal trig functions, you just flip all those. Okay, so just to kind of get back in the swing of things here, here is a triangle. The sides are 5, 12, and 13. Let's evaluate the 6 trig functions of theta. So sine of theta, what would sine of theta be? Well, sine of this angle, sine is opposite over hypotenuse, so 12 over 13. What would cosine of theta be? Well, cosine is adjacent over hypotenuse, so 5 over 13. Tangent of the angle is the opposite side over the adjacent side, so that would be 12 over 5. Your reciprocal functions, CSC, theta is cosecant, which is just the reciprocal of sine. That would be 13 over 12. Secant, which kind of looks like cosine spelled backwards. I know it's an E instead of an O. That's your reciprocal function of cosine. So that would be the hypotenuse over the adjacent side, so 13 over 5. And then cotangent is just the adjacent side over the opposite side, or just the reciprocal of tangent, so it would be 5 over 12. So if you need to go back to this page in the video when you're going through homework as a guide, that can be kind of helpful for you, just remembering what your 6 ratios look like. So to make this a little more difficult, what we can do is maybe being told one of the ratios, being asked to find the other 5. So here we're told that the cosine of theta is 5 over 6. And we want to find what sine, tangent, secant, cosecant, and cotangent of theta all are. Well, we can draw a triangle to help us out. I did that for us. Now let's label what we know. We'll put a theta down here, which I also did for us. And now if cosine of theta is 5 over 6, that means the adjacent over the the adjacent over the hypotenuse is 5 over 6. So from theta, the adjacent side would have to be 5, and the hypotenuse has to be 6. So we're good there. So using that, can we find the other 5 ratios? Well, secant's pretty easy because we can just flip-flop this. So the secant of theta is 6 over 5. But to find the other 4 ratios, we're in a bit of a pickle because we don't know what our third side is. Luckily, we know the Pythagorean Theorem, so we can find the third side. So let's do that now. We'll just call that x, I guess. X squared plus 5 squared is 6 squared. So x squared plus 25 is 36. Subtract 25, x squared is 11. And then we take the square root and we get the square root of 11. We're going to go ahead and leave it like the square root of 11. And now we have all 3 sides, so we can fill out the rest of our trigonometric ratios. So sine of theta would be opposite over hypotenuse, so square root of 11 over 6. Tangent of theta would be opposite over adjacent, which is square root of 11 over 5. Cosecant, we would just flip sine, so it would be 6 over the square root of 11. But like we saw on the first page, we don't want to leave our fractions with square roots in the denominator. So we rationalize the denominator, and we get 6 times the square root of 11 over 11. We'll do the same thing for cotangent. So cotangent would just be flipped tangent, or the reciprocal of tangent, 5 over the square root of 11, rationalize our denominator, and we get 5 times the square root of 11 over 11. You do have a handful of problems like that in your homework. Okay, so before we move on to our next piece, I want you to take out your TI Inspire calculator and do one quick check for me, okay? So you're going to be on just like a calculator page, that's fine. Go ahead and press the home button. And now we're going to change a setting. So we're going to go to settings. You're going to click 5 or click settings. You're going to go to document settings. And then where it says angle, you should change this for today to degrees. If yours is already in degrees, that's okay. You can just back right out. But if you have radians, please change that to degrees and then press OK. You can go back to your current document. If you're using another calculator, most of them default to degrees, especially like the little baby calculators. But if you're using another graphing calculator, you can check the same way. So if you have a TI 83 or an 84, you can press menu, and then I think it's just right there for angle. You just move over to degrees instead of radians. So to use our calculators to solve for missing sides, this is something we did a lot of in geometry. So take this problem here. This angle is 62 degrees. That's 6. We want to find what x is. We can't use the Pythagorean Theorem, so we have to use trig. So how we did this, or how we're going to do this, is we're going to take our angle, and then I like to label our sides. So from 62, my hypotenuse is here, my opposite side is here, and my adjacent side is here. Now we have to think which of our trigonometric ratios use what we have to work with. So 6 is our adjacent side, x is our hypotenuse. Which trig ratio uses adjacent and hypotenuse? Well, there's going to be 2 of them. The one you're more familiar with is cosine. We can use cosine. We'd say cosine of 62 is equal to 6 over x. we could also use secant. If we use secant of 62, we would get x over 6. We're going to get the same answer no matter what. We can just roll with cosine for right now. To solve this, I like to put this over 1 and treat it like a proportion. Then I can cross multiply. X times the cosine of 62 is equal to 6. Divide both sides by the cosine of 62. X is 6 over cosine of 62. I put that in my calculator and we get something. 6 divided by, to get the trig functions, you press the trig button. Then we say cosine 62, enter. 12.78. Awesome. Go ahead and give this next one a try. You can feel free to pause the video, then I'll walk through how I would do it. Okay, so from 25 degrees, x is our opposite side, 16 is our hypotenuse. Which trig ratio uses opposite and hypotenuse? Well, that's sine. Sine 25 is equal to x over 16. Put that over 1, cross multiply. 16 times the sine of 25 is equal to x. Put that in our calculator, 16 sine of 25. We get 6.76. Cool. So very similarly, if you're asked to solve a triangle, what that means is you want to find what all three sides measure and what all three angles measure. For this problem in particular, we have a 90-degree angle given to us, we have a 37-degree angle given to us, and we have a 5 for a side. So we only have one side. The easiest thing to find is the missing angle, because if you remember from geometry, the three angles of a triangle have to add to 180 degrees. So to find angle A, you would just take 180, subtract 90, and subtract 37. Most of us are pretty familiar with that by now. We get 53 degrees. So the measure of angle A is 53 degrees. And now we got to find the sides. So to do that, we're going to use trig. For this, you have a lot of options. You could use the 53-degree angle, or you could use the 37. Doesn't matter to me. I'll just use 37. We'll find AC. We're going to call this little b. So b is the opposite side from 37. 5 is the adjacent, so we'll use tangent. I'll go ahead and pick a different color, just so we can follow this differently. Tangent of 37 is equal to b over 5. Cross multiply, b is equal to 5 times tangent of 37. Put that in our calculator, 5 tangent 37. We get 3.77. And then to find our third side, we'll call it C, little c. We can use Pythagorean Theorem at this point. We could use trig. You got a lot of different options. I'll be crazy and do some trig. I'm going to use the secant of 37. Secant of 37 is the hypotenuse over the adjacent side. You could use cosine, you could use sine, you could use cosecant. You really can use any of those four, or Pythagorean Theorem. Cross multiply. C is equal to 5 times the secant of 37. Put that in our calculator. We get 6.26. And there we just solved this triangle. We found all three sides. Okay, so the last thing we're going to review from geometry and algebra 2 is our two special right triangles. So the first type of special right triangles we have are 30, 60, 90 triangles. 30, 60, 90 triangles always follow this pattern, where the hypotenuse is just double whatever the short leg is, and the long leg is whatever the short leg is times the square root of 3. That makes doing problems like this very, very easy to do without needing to use trig. So if the short leg is 4, y is just double that. So you can think of this like a proportion if you want. So you can have like 4 over x. I don't even need to explain it like that. Sorry. Just think of it like this. 4y, x. 4 represents our single length. Double that for y, you get 8. Long leg here, you take the short leg times the square root of 3. So it's just 4 times the square root of 3. What I was getting at is you can kind of create a general triangle where I call this 1, I call that 2, and I call this the square root of 3, and then use proportions to help you solve. I'll do that over here. 1, 2, square root of 3. So to illustrate how that would work here, we want to find just x. So you can use this, as these are similar triangles. You can do something like 10 over 2 is equal to x over the square root of 3. Cross multiply, 2x is equal to 10 times the square root of 3. Divide by 2, x is 5 times the square root of 3. Alternatively, you could say, okay, well, if that's 10, I know this is 5, and then I take the short leg times the square root of 3 and get 5 times the square root of 3. Both ways work fine. This way is actually sort of nice for when you're given the long leg, because if you're given the long leg, you can do something like this. Well, I'm going to go long leg 10 over long leg up here, square root of 3. And that is equal to, if I want to find x, let's say, x over short leg is 1. Now I cross multiply. I get 10 is equal to x times the square root of 3. So x is equal to 10 over the square root of 3, which we could rationalize. I'm running out of room. So x is equal to 10 square root of 3 over 3. And then to find y, I would just double that because the hypotenuse is just double the short leg. So y would just be 20 square root of 3 over 3. Our other special right triangle is a little simpler. It's a 45, 45, 90 triangle. In a 45, 45, 90 triangle, the legs are both the same. The hypotenuse is just whatever the leg is times the square root of 2. So for this particular problem, if this length is 7, y has to be 7. And x would have to be 7 times the square root of 2. Now the only place this gets a little tricky is if you're given the hypotenuse as an integer. The idea here is x times the square root of 2 is equal to 5. So to solve for x, we would divide by the square root of 2. And then we'd rationalize. So you get 5 square roots of 2 over 2. And you'd get the same thing for y. Now the last thing, I did skip over it, just this language, angle of elevation and angle of depression. Angle of elevation is the angle in which you're looking up at something. Angle of depression is the angle at which something's going down. So if you're looking up at a plane with an angle of elevation of 10 degrees, and the plane is 30,000 feet in the air, how far over horizontally is it? Well, we just run trig. So this is our opposite side. This is our adjacent side, so we can use tangent or cotangent. I'll go ahead and use cotangent. So cotangent of 10 is equal to x over 30,000. Cross multiply, x is equal to 30,000 times the cotangent of 10. Put that in our calculator. Cotangent of 10, and we get 170,138 feet horizontally. So when you ever see angle of elevation or angle of depression, that is just the angle in which you're looking up or down from horizontal. And that wraps us up with our big trig review.